Hey guys, welcome to lesson 2.1.2, day 1, Transformation of Parabolas. Today we are going to focus on how parabolas are graphed and how to go from graphing form to immediately knowing where on a graph a parabola will move, approximately how big it is, that sort of thing. So, the general equation or parent function of a parabola is the parabola that was absolutely the original, right? There are no movements from zero. It's the same, it's the standard shape and size. The key thing is that it doesn't move anywhere, right? It's just going to be sitting at 0, 0, right? The vertex is at the origin, and it's just our standard parabola. Okay, and then anytime we add all these other little pieces to it, it's going to transform our parabola in some way. So we're going to explore how each of these letters affects the graph of our parabola. So let's start with A. A is the number at the very front of our equation. So let's go ahead and play around with this guy right here and see what happens when it's a positive number versus when it's a negative. Oops. All right. So here's my original parent parabola, and here's the new one. Okay, notice how my A value up here is positive 1. When I turn it negative, it flips me over and it opens downwards. So we will put that it opens upwards if it's positive. And it looks like this. Okay, an example of that would just be any basic equation without a negative sign, right? Like 2x squared would cut it. So, on the other hand, when your A is negative, we saw that it flips down. Whoops. It opens downward. Alright, so an example, I would just take any old parabola equation and throw a negative sign in the front. All right. So next, let's actually explore the A value itself. Okay, if it is a number greater than 1, now in our equation here that we're playing around with, we have the number 1. If it's a number greater than 1, let's put 2, 3, 4, 5, 20. Okay, notice how it's getting skinnier. Okay. But when we put a number smaller than 1, like 0.5, 0.8, oops, 0.9, 1/16, it gets really, really wide. Okay, so in my table, I notice that when it's a bigger number, it gets skinnier. I know that's a little weird, but this is something called a vertical compression. Or sorry, not compression, stretch. Mixing up my words. It gets skinny. If you think about it, when you pull on a rubber band, it gets skinnier, right? And that's kind of what's happening with this vertical stretch. So an example would be, it could be the same thing we chose up here, right? 2x squared or 4x squared, anything with a big enough number. So, on the other hand, when we have a number that is smaller than 1 but greater than 0, so it's going to be like a decimal or a fraction, then it's going to get wider. Okay, and this is called a vertical compression. If you think about it with the rubber band example, if you take a rubber band and kind of squish it a little bit, then it becomes wider horizontally, right? So an example of that could be 0.4x squared. Or you could go, oops, 0.4x squared, or y equals 1/4 x squared. Okay, notice how these are fractions and decimals. All right, moving on to the letter H. Okay, notice H's position in our equation. It's the number inside the parentheses. So when H is positive versus when H is negative, Let's change this back to being 1. Here we can see that if it's a positive h, it moved to the left, right? If there was no h at all, it stayed at the middle point at 0, and when we have a positive number in here, it moves to the left, right? Farther and farther to the left. Versus when it's negative, it moves to the right. It's kind of opposite from what your heart would want it to do. Okay, so you got to remember that left and right movement is always opposite in terms of the sign versus what your brain would assume it to do. So when it's a positive, we move to the left. Put a little left indicator here. Okay, we can put an example as like x plus 2 squared. All right, and opposite, if h is negative, we move to the right. All right, now for k. Let's look at our general. K is the number just chilling on the end. In our example, k is 3. So when k is positive, in this case it is positive, right? Let's see what that did. If we just took away our k, we were right at the bottom at 0. When we had a positive k, we moved up, 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 right? That plus sign makes us move up. So sure enough, if we make it negative, we're going to move down, right? It's just moving lower and lower. K, unlike h, is not opposite, right? It does what your brain would want it to do. A positive would move it up, and a negative would move it down. Let's do some examples. So here we have, we could do x squared plus 4, right? This means this parabola, the only transformation that happened there is that it moved up 4. Whereas here, the x squared minus 4, that would mean we took our parent function and we just scooted it down by 4 values, or 4 units. All right. So we can also find the vertex very easily. Fun fact, graphing form of an equation is also commonly referred to as vertex form. Okay, they're the same thing. And the reason is because you can get the vertex in 2 seconds just by looking at this equation. So the way you find the vertex is that you take your h value and you change the sign, so that's why that negative is there, and then you use your k value. Okay, so in our example, let's see what I mean. In our example, h is negative 2, k is 3. So the vertex will be the opposite of h, so it's going to be positive 2, and then k as is, so 3. Okay, remember I took the opposite sign of h and kept k just as it is. And the reason we do the opposite of h is because, remember, with h movement, it was opposite, right? Positive was left, negative was right. And that's why we have to take the opposite sign as well. All right, so let's go ahead and practice. If we can look at this equation, we can figure out really fast what every single piece is going to do to this graph. We can right away have an idea of what it's going to look like. So let's start with our negative sign here. The fact that we have a negative sign is going to tell us that we are going to flip. We're going to open downwards. Oops. Oh, geez. Okay, so flip, open, down. So that's one piece. Next, we have our actual a value. Now notice how I'm handling them separately, because the negative has its own effect on the graph, and the number itself has its own effect on the graph. So that 4 is our a value. All right, 4 is our a value, and it's a number that's bigger than 1, so that means it's going to be skinnier. It's going to be vertically stretched. I know this is a lot of information to absorb in one sitting, but I promise that as you practice with it, it's going to become like second nature to you. All right, this -5, that is our h value, and because it's negative, we're going to move to the right. Okay, and that leaves us with k at the end here. That's going to move us up 2. We should actually move to the right 5. All right, so just like that, we can instantly have an idea of what this parabola is going to look like. All right, next page. Oops, I should clear that. Okay, so now we're going to kind of work backwards. Now I have descriptions, and I want to write the equation. So we want to follow this in the order that we know our equation to be in, right? So we know it goes y equals ax minus h squared plus k. So let's take a look here. We have a reflection. That means it's going to flip. So we need to add a negative sign. Next, it was shifted to the right 5. And so that means we have an h value of -5. It's always the opposite with left and right. Next, we have shifted up 8. That tells us we have a k value of 8. All right, and lastly, we have a vertical compression by a factor of 0.3. Notice how it is a smaller number, so that's why it's a compression, and that tells us our a value is 0.3. Okay, now that we have all that information, we can just stick everything in its respective spots based on our equation. So we got our negative sign, and so our a value comes next. Our a is our a is 0.3, so we're going to put a 0.3. That, like, x is always there, don't worry about that. H is -5, so we're going to have a -5 here. Oops. Okay, and then we get k plus 8, because it's a positive 8. And that is it. That's our full equation. Just, follow the letters. All right, last problem here. Now we are going to figure out what the vertex is of this equation. Now remember, that's really fast, right? We've just looked at the h. Our h is -3 here. Our k is 5. And so now we're like, okay, well, opposite of h, comma k. So our h is -3, and our k is 5. And remember, in the vertex, we got to take the opposite sign of h. So instead of -3, we will write +3. K doesn't change, so it's just 3, 5. And that is pretty much all you need to know about transforming parabolas.